Broadcasting from the Any Hour Services podcast studios, I'm your host, Mike Wilson, and on this episode of In the House, we're going to be talking about pressure-reducing valves, PRVs, stuff like that. Let's go. In the House is a podcast about the major systems in the house: electrical, plumbing, heating, and air conditioning. This week, I'm joined by Scott and Dwayne in the studio. It's possible that Ricky will join us later. What you guys might not realize, I mean, I say it every time they're on the show, so maybe you do, but they are the managers over the plumbing service department at Any Hour Services. They're busy. They're nice enough to take time out of their schedule to come and do the show with us. Thanks for being here, guys.
You bet. You're welcome. Glad to be here.
So let's dive into this. Did I say that right at the beginning? Because, I mean, PRV is what we call it, and that's what I was going to put, but I was like, maybe I should say what that means. And I said pressure reducing valve. So was I right with that, or?
You are right with that.
Okay.
So it is a pressure reducing valve. And, but oftentimes we refer to it as a pressure regulating valve.
Okay.
And the reason being is that homeowners, nobody wants less pressure and less volume when you're in that shower, especially if you got a nice rain head. You want it to, be almost a deluge coming down on you.
Right. You don't get a whole lot of calls being like, the pressure's too good in my house. Could you come and fix that?
And but pressure can be, out of control and way too high, and it's just not good for your system. You might enjoy it, but it's not good for your system, and nobody really knows. It's one of those things you don't know.
You don't know what?
If there's high pressure or low pressure. It is what it is.
Gotcha. So what is a PRV? Like the device? What is it? What does it do?
It's an actual device that's located right above your main shutoff valve in your home. So where you turn your water on and off. I don't really know how to describe it, but it's a brass device that has a little cone head on it.
But what's it doing? The mechanics of how it does it.
Yeah. So what it does is it'll actually reduce the flow of incoming water, so that it's delivering what we say it's going to deliver. So there's a setting on there that gives us how much PSI we're going to get.
So here's something that I'm thinking about. I mean, the reason in my mind that it's a pressure reducing valve is that all that valve can do is reduce pressure. It can't actually increase the pressure coming to the house.
Correct.
The pressure is what it is, and the reason they make these pressure reducing valves is because more times than not, the pressure is too high because the city or the municipality or whoever is trying to feed, they're not usually feeding one house. They're feeding a neighborhood, and so you've got these pressures that fluctuate, and so you want to try and regulate it because, like you guys were telling me before, that the manufacturers of all of the fixtures in their house, they're engineered and designed to work at a certain pressure, right?
Yep.
And when that pressure is too high, what starts happening?
O-rings can fail,
causing leaks.
Causing leaks. Just parts can wear out.
Mm-hmm.
They're more abrasive flow. Water flow is very abrasive at times, and so it can.
You mean the Grand Canyon? Like water eats through rocks, like the Grand Canyon?
Yeah.
Okay. Are these required in a home?
So the code says that anything over 80 pounds of pressure must have a regulator.
Got it.
That's the code in every code throughout both codes that are used in the United States. And so it's just pretty much a standard that if you measure over 80 pounds, it needs a regulator.
If there was a circumstance where somebody had 75 pounds of pressure, technically, would they not need a regulator or a reducing valve?
Yeah, technically, they wouldn't need one. The issue we run into is that municipalities are always changing and growing, and they bring new things on. They up the pressures as way across town where there's property available, the homes are going in, and so they can jack up the pressure to compensate for that new home, the new development that's a mile and a half from you in your community, but they still need the water pressure, and so the cities will boost their pumps and their flows up to compensate, and then now suddenly you're not at the 75 pounds.
When were these things introduced as a requirement? What I'm trying to get at with this question is, are there homes that are old enough that okay, these homes might not have, because they weren't required, they might not have a PRV on?
Yeah, being the ancient one here that knows the history and stuff. Did they have
a PRV on the Ark? That was it? Like Noah in the Ark, like it was a long time ago. You're old. Like you paused. I can't tell if like you were offended by that or you were trying to remember if it was on the Ark.
Wait, was I on the Ark? Scott and I were just having this conversation about memory yesterday.
Well, that's not doing well for you. Like I'm not that old.
Well, was I? No, I started seeing them come in regularly in about 1985, and somewhere in the 90s, it pretty much just became the code and things. And so anything that's built currently, whether it has high or low pressure, almost every developer's you're just putting in a pressure regulating valve automatically.
Sure. But like if you have an old home like that was built in the 80s, 70s,
right,
60s, like is there a chance? Well, because
it's more likely they don't have a regulator.
But when a plumber comes out there, more than likely they're checking the pressure and they're going to like talk to him like, hey, when your home was built, they didn't have these devices. It's a really good idea. Here's why. So some of those homes still might have one, right?
Mm-hmm. Mm-hmm.
So how does someone know, like, is there a place that they need to go and look to tell if they have one?
Yeah, I mean, that's kind of where I was going in the beginning, is it's located right off your main shutoff valve. And that, if you don't know where that is, it's hard to explain. Typically, it's on the front of your home. But like I said, it's right above your main shutoff valve in your home. So
if you know where the main shutoff valve is to the house, usually the PRV is going to be right there by that valve after it.
Yeah, within a foot of that valve usually.
Okay. In the last plumbing episode that we did, we actually talked about sediment building up in the water heater, and this PRV, if you were to cut it open, you'd see that there's, moving parts and pieces that help to regulate that. Do you ever have like sediment get stuck in those and like cause them to fail?
Yeah.
Is that a common thing, or?
They do fail. I mean, we don't really tear into why they fail.
You don't do an autopsy on every PRV that you pull out?
There is a screen. Mm-hmm. There's a screen that a mesh screen in there that's larger than your screen on your windows and stuff, but I don't know exactly how to describe it, but it can catch, if you've got a lot of sand and sediment and little rocks.
It's supposed to catch the big pieces.
It'll catch the big pieces that come in and things, but yeah, as far as that, we don't really know why they fail. There is a rubber diaphragm in there that the water passes across, and so if a small sand grain comes in and gets wedged in there and lodged, and then it could cause it to bypass and not regulate anymore.
How long do they last when you put them in?
I mean, we're seeing them 6 to 12 years, something like that. It's going to depend on the water type. If you have lots of minerals, lots of sand, things like that, or high pressure, it's going to work harder. So
what
really
affects it more, the quality of the water coming in or the pressure of the water coming in?
I got to say both.
Both.
Yeah.
Yeah, both. I mean, if you've got say the city's giving you 120 pounds, our normal setting wants to be 60 to 70 pounds, so you're double the pressure coming in. So it's working hard to hold back the flood waters in your home. So it's going to be exercised a lot more. But in the meantime, anything that's rubber, I mean, the rubber just turns hard and brittle over time, and that diaphragm modulates, and it's supposed to be able to move up and down, and so it maintains a constant pressure and keeps that 120 pounds back behind it, while as you open up one faucet, two faucets, this tub, that diaphragm modulates and bells up so that more water can flow through while maintaining, not letting that 120 pounds in. Well, it can calcify, and they just turn hard, and then they stop diaphragming. They stop moving up and down, and your water flow can be affected. That's one of the things that we find, is that suddenly you've noticed that, well, I turn on a faucet and I'm really high for a second, but then it drops down and it's not as strong as it used to be. That's one symptom of a failed pressure regulator.
Gotcha. What's more common, that it fails and you end up having that like decrease in pressure? And are you really having like a decrease in pressure? I know you really are, but what I'm trying to get at is that inrush that you have at the beginning that you were just describing, is that higher pressure than it's supposed to be, and that PRV is just stuck at the 60, but since it's like stuck there, you've got this build up back pressure and it like shoots out the, I don't know if that question made sense, but
No, that's a really good, yeah.
It's more that initial rush is based on the water was stagnant and built the pressure, so it built slowly in your system. And so when you turn it on, you get just that rush of what you would normally get. But because nothing's coming through, then everything drops down.
So you'd get the rush of whatever the PRV was set to,
right,
the
it's
60,
not,
70 pounds.
Or
right,
more,
it's not,
or more. If it's filled, it can be, you might have the rush of the 120 pounds, and then it decreases.
Well, see, that's where I was ultimately going to go, is when they fail, do they fail more of like it's failed and you're getting the pressure that's coming in, you're getting a higher pressure than you should, or do they fail and it's
Great
reducing the pressure?
Right. So that diaphragm it modulates up and down, and I've seen them where they get stuck in an open position and you don't notice there's a high pressure, but the volume's also great. There are times when you go in and we put a gauge on and we test, we open up a faucet and it drops way down, and that means the volume isn't there behind it, so it might be in a semi-closed position and not allowing the volume of water to come through that it needs to happen. And that's kind of the test that we do with our test gauge and how we can tell what's happening with that pressure regulator.
So we'll get, because I want to go over like how to,
Test.
how can someone test, like how can they know how it is? Because but I'll go over a couple more things first. We talked about how long it lasts. Surprise, surprise, it depends. But my next question actually was, let's actually just go to, how do you test? And I'm thinking more from a homeowner. Before we go into, you need to have the little, water pressure gauge. Is there anything that a homeowner can do to go and see, do I have high pressure or low pressure? Are there any signs, or is it that indistinguishable?
I would say it's less easy to determine without a gauge. It's almost like high blood pressure. You don't even know you have it. You know what I mean? And so it's really hard to gauge unless you have the right equipment. It's going to be a lot more difficult. You can maybe do a flow test, but I don't even know if that's really going to get you where you want to be. Okay.
Well, then let's go into the gauge, because the gauge that you get to test it's not super expensive, $10, at the hardware store. And it's got a hose bib looking in, like the male or the female end that you'd screw onto a hose bib. And then it's got a gauge with needles, that move back and forth, and it's measuring the amount of, the PSI. Is that what it's measuring there? So, okay, talk somebody through. Let's say they do go get this gauge at the store. How do they actually test it properly to see what pressure they have?
Yeah, so we like to start off with the water heater. There's at the bottom of the water heater, there's usually a drain valve.
Okay.
And it's a really good spot to put it on. For one, now we're inside the home. If there is a pressure regulator, we're well in the home and we're measuring what the home is. And so you would put the gauge on there and then open it up and see what it goes to and take that reading. And if it jumps way up and way high, then what we do is we go open a faucet, just a normal faucet, hot and cold, and then walk back and look and see what the gauge is. And then the next step.
Do you do that because, you've got a TMP, like a temperature and pressure valve on the side of the water heater, because heat and pressure can build up. Do you go open that valve because you can have a false high reading?
Yes.
Okay.
Yeah, definitely, because you might have just gotten through with the water heater cycle, and maybe you don't have the expansion tank and the proper things on your water heater, or if you do have one, it might have failed. But that's another check that we do to help us see how fast does that drop down. And these tests are always better if you have two people, because it's really neat to sit there and watch the gauge as somebody opens the faucet, and then you watch the gauge and it'll drop down. And if it continues, you leave it open, and if it drops down slow and continues to drop down, then that's one part of our diagnosis that maybe there's an expansion tank issue. But it'll eventually bottom out and say, okay, this is our flow through one faucet. And we try to do the faucet because the toilets have a bit more inflow to them. The faucets are a little more regulated and things. And ideally, you want to see, once it's regulated, then you turn the water back off and see what it climbs back up to. And if it was, say it was 100 to start with, and it drops down to 50 and then goes back up to 60, and then you watch it for a minute and it holds there at 60, then we know that there was probably some thermal expansion or something, that was pressurizing. But you might need to watch that gauge for a minute or two, because we call it the creep, where if the regulator has failed, then it can kind of slowly creep up. The water heater's not on, so we know it's not thermal expansion, and it might just slowly creep up. So watch it for a minute and see what happens, and then open up that same faucet again. We like to see ideally a 5 to 15 pound drop in pressure with one faucet is considered a normal flow. And that means our regulator, if it goes from 60 down to 50 and then back up to 60, regulator is pretty much functioning where it should be. And as long as it kind of just goes down at a normal rate, if we shut the water off and we've seen the needle bouncing all over the place, that either means the regulator, if you have one, is totally kaputski and totally shot, or you don't have one. If you shut the water off, the water flow stops immediately, and the needle bounces around, you don't have a regulator.
And is it a noticeable bounce, meaning it looks like like if it was spring loaded and it's sitting there going like this, or you're saying it's like consistently like a steady back and forth?
No, it jumps up and then wiggles.
Got it. So like the little door stopper that you'd play with when you go,
yep,
so
exactly.
it would look like it's doing that.
Yep,
So it'll
exactly.
pop back up, do the little wiggle,
Yep.
and then does the wiggle ever stop?
Yes, the wiggle stops.
Talk about weird things here.
So if you have a water heater and you sometimes those on the plastic drain valves on the water heater, if I were going to be doing one, I would flush a little bit of water out of the water heater as well, because when you take that gauge off, you'll almost always have this black nasty stuff, and it can get in, and I don't know if it damages the gauge or not, but anyway, it's just.
So are there plumbers that would disagree and say the water heater isn't like a great place to go because of that? Like you're gonna have hot pressure, like you get what I'm saying? Like,
yeah,
because there's gonna be plumbers listening and they'll be like, well, this is what I do.
Yeah, well, if I can't do one off the water heater, I go over to the washing machine and see how accessible the hose, because they've got hose threads on that too, and check the valve out. Now, if I don't want to touch that valve either because it's too old, then I would just go to the hose faucet, either in the front or the back.
Gotcha.
I would probably choose the backyard one if it's accessible, just because I know that sometimes we see homes that the front faucet might be taken off before a regulator, and so we're measuring the city pressure, and others, the regulator controls everything.
So somebody, asked a question on some video that I made. It may have been on one of the ride-along videos that we have on YouTube, but the question was, how come you don't take the pressure off of the outside hose bib? And is that the case, is because you have a higher chance of it coming off of before the PRV?
Well, that, and then a lot of the hose bibs have an anti-siphon device on, and it allows the pressure to come in, but it won't allow it to go back. So when you open a faucet, it won't change.
Gotcha.
And so we don't know what it drops down to. You almost have to have a faucet running, come back out, open it up, let the pressure drain off a little bit, tighten it back on, and see what it is to get a reading. So it's just a lot more difficult to get an accurate reading, because you can sit there, and if it's 100, it'll stay at 100, even if you open a faucet, because of the check valve that's in those hose bibs.
Okay. All right. So is it, if somebody was concerned with, actually, if there are any plumbers watching, let me know like where you go and check where you attach your pressure, tool to see what the pressure is in the house. If you do something different, or if you do it the way that Dwayne just described there. That makes a lot of sense, though, what you're saying, as far as now, when you first described the water heater technique, where you said put it on the bottom of the valve, open it up. But then later you said drain some, like flush a little off first.
Yeah, just because there's always going to be debris.
So the process would technically be flush a little first, then put the meter, or what do you call it?
The gauge.
The gauge. Then put the gauge on. If you flushed it and then put the gauge on, as long as the burner isn't running, did you probably relieve the pressure from the cycle just finished?
I'm only talking maybe a cup of water. I'm just talking just barely a little that gets the concrete wet.
Okay. Gotcha.
Just to get the debris and rust and sand that might be right there.
So it's not to relieve pressure, it's to clear any of the debris,
the valve,
or the sediment that's down there at the valve. Okay. And then you said if you plug it in or you put the gauge on and you have like a lot of pressure, like does it matter what that pressure is, because your next step is always to go and open a valve? Or are you looking at that pressure to know, like, why are you looking at that initial high pressure?
Well, just because it's there and available to you.
Well, and the regulator's
why wouldn't you look? That's why you put the gauge on, Mike. I'm logically trying to walk through like the purpose of these diagnosis steps. And when you first explained it, sorry, I'll come back to you in a second. When you explained it, you were like, okay, plug it in, put the gauge on, and if you see, the way you described it was, if you see high pressure, go open a valve. But then the way you were describing it, it sounded like, I'm going to go open a valve anyway.
See, and that's exactly it. Do I pay attention much to the first reading? It's interesting to note, but it's not. I don't care what that says.
Okay, that's what I was trying to figure out.
I want to see what the system is after it's been opened and then closed again.
The reason I try so hard to like really try and understand what you're saying is that I go back and watch these episodes because I then will make a YouTube video showing somebody how to like check their pressure. And I want to make sure that I understand it well enough that I can then teach it to somebody. So understanding why you're looking at certain things and why you're doing things, it's really just to help me more. Scott, you were going to say something. Hopefully you didn't forget.
No, yeah, I'm not, I wasn't on the ark, so I'm good.
Wow. Wow.
Oh, I'm never going to have a conversation in the hallway with you ever again, divulging my secrets and my innermost feelings, and then you just trash me on the...
You said it right here on this podcast.
I did, didn't I? Okay.
So have you been saving that up though? Because you had that one on deck, like really like ready to go.
No, it just came.
Because I was like, hopefully you don't forget, and you're like, I wasn't on the ark. I still remember things.
Yeah, no, sorry.
I agree with you, Dwayne. That was very rude of him. Can't believe he would do that.
We're still friends.
It's the rudest I'll ever be.
That's a good level of rude to be. You're old. I guess it could get ruder, but that sounded pretty rude.
It could.
Okay, go ahead.
I own it.
Now, have you forgotten?
No.
I own it.
So back to the regulator and what it does is it has the ability to set the pressure. You can increase and decrease that. So if you're getting over what it's capable of producing, it's not working. Does that make sense? So if your regulator's set at 50 psi and you got 100, then it's not functioning the way it's supposed to.
Well, here's the thing. When you say that, like on the regulator, when you look on it, there's not a dial to set it at that pressure. You got to like tune it in.
Yeah.
Right? Because that was actually one of my questions. Is like does it come? Do you have to adjust every regulator that you put in, or is it pretty like it comes set at 75 from the factory and it's like you can set your watch by that?
It comes preset at 55.
55.
I thought it was 45.
45?
Yeah.
No, I think it's 55. We'll look it up.
But
it's preset.
But it's preset at something.
But the problem is that what was it preset at? And if you've got 140 pounds coming in, that 45 or 55 might measure 75 without any adjustments, just because the incoming pressure is higher probably than what, there's got to be a standard that the manufacturer says, is set at 55 psi
based off of this
at 100 psi or something,
So you have to adjust every one that you put in.
Yep.
Yeah.
Okay. That makes sense.
And that's done with that same gauge.
That's what I was going to say. So back to your point that you were making, like you were like, if it's set at this, like how does someone know what it's set at?
Yeah, and that would just go back to your gauge.
So you got to use the
gauge.
Because regardless, is it less about what the PRV is set at versus what the PRV is like doing, or like the pressure that it's reducing it to? Because it sounds like the pressure could be different depending on the incoming pressure. And when you put your little gauge on, like you can open it and close it, that you can loosen or tighten, whatever you want to say, to like give you a little bit more or a little bit less. But actually, I have no idea where I was going with that question. But
no, so when you go to adjust that,
yes,
if you do have a new one that's installed. Now, we don't recommend touching them if they're more than a year old.
Really?
Kind of gets to the cringe point, just because
1 year.
Yeah, I would tell the customer, look, if I ruin it or I adjust it and you get high pressure and we mess with it, now you've got to buy a new one. And so I'm managing that. If it looks older, if they don't know how long it's been, but a year is kind of our limit that we try to tell our guys, and we all fall into it. I mean, and we do this because oh yeah, let me see what I can do for you. And then suddenly, well, it was working just fine before you touched it, so I want it for free. How often do we hear that? And so it's that. So we just kind of, as our technicians, it's like, hey guys, don't touch it. It's still, that rubber diaphragm is probably still malleable enough within a year's time frame. But beyond that, the calcium buildup, the hard water, the stiffness of the rubber, it gets to be scary. But to adjust it, then you would go, the nut on there goes in to increase and out to decrease.
Like lefty loosey, righty tighty?
Yeah, well, it depends on
So when you say in, left or counterclockwise?
Well, it depends on
that's
which,
clockwise.
Depends on which side it's the nut's on.
Does it?
Clockwise.
No, it's always going to be.
It's clockwise.
It's always,
sorry.
I'm like, well,
we didn't have these things on the ark, okay? Come on.
You just had a door that you'd open to like let more water in, or not let as much water in. So back to if it's more than a year, is that because that makes the device sound pretty fragile. I mean, I'm just saying, like, is that because you're getting sediment in, the diaphragm goes bad? That, like, what's going to fail after a year of it being used?
I'd say yes and yes to what you just said.
You would. You said it really aggressively,
yeah.
Scott.
Well, yeah, you nailed it.
Oh,
so I'm just jumping on board here. It's the first thing that really protects your home. Like it's the very first thing as you come in, except for the shutoff valve. And so you can't control any of the mineral, you can't control any of the pressure. That's what it's for. It's almost like an anode rod in your water heater. It's sacrificial. It's there designed to protect your system, and it is going to fail. And so you want to get it set in the beginning, and you want to leave it there. That's really what it's designed for.
Seems like if it was sacrificial, they would like make it so that you didn't have to like resolder the pipes every time you put it in. You'd like unscrew it, put the new cartridge in.
They make rebuild kits.
Yeah.
Ask any plumber if they've ever been successful in installing a rebuild kit, and it works. I've done it 3 or 4 times. Never worked. Couldn't get it. Brand new rebuild kit. You spend less money for the rebuild kit.
Somebody that's been successful with it. Like, how do you sell a product that no one can install right?
I bet if we took a survey, there's probably nobody that says that it's ever worked.
And you said, it's actually not terrible to replace if it's installed properly in the right device. It's really not complicated.
So, what was I going to say? I was going to say something about.
Well, back on, we kind of jumped over when we were talking about using the gauge and setting it.
Yes.
What you would do is you would look at your gauge, see where it's at static without any water running. And then I always go and open a faucet again and then see what it comes back up to and make sure it comes back up to that level. And then if I want to increase it, I go and increase it. And I would screw it in. Maybe 2 turns is about 5 pounds, I think, typically. And so you would turn it in twice. You come back and check the gauge. But I also open a faucet and close it again to see where it settles into.
So I remembered the question that I was going to ask, because you said I started going there when I said like a year, like you won't touch it after a year. How do you know? Like I could see that as long as it was set right to begin with, but like, how do you know if you're coming back in and like, hey, this thing was like put in a couple of years ago? How do you know that it was like set properly to begin with? And if it wasn't set properly to begin with, is the homeowner just like, guess I got to put a new one in?
Well, it's preset by the manufacturer, so it's within the range. They might not like the amount that it's given him. However, it is within the range that it's doing its job.
Okay.
So anytime we read more than 75 pounds, after we've adjusted, taken out the thermal expansion by opening the faucet, that regulator is designed to go from 35 to 75 pounds. It's adjustable in that range. If it ever goes above 75 pounds, it has failed.
Do you ever have someone say, okay, I get it, I might have to replace this thing, and I'm okay replacing it if you adjust it and I end up with high pressure? Do you ever have somebody be like, but try first?
Yeah. There's people that want to take the risk.
And when you do that, how often, like, are you successful with it? What are my odds here?
I don't know.
It depends.
Yeah, it's really 50-50 on that one. It might work, it might not work. It just depends on what risk you want to take.
I think it helps to think of it as a sacrificial part, to think that like, okay, this isn't supposed to last forever. I mean, nothing is, but it really feels, in my mind, like since that thing is like welded in place, soldered, like they're like, that seems like it's supposed to be a pretty like substantial part that's permanent-ish. Yeah. But anyway,
it's like everything. We expect things to last 20 years, and they're just not. They're just not lasting that long anymore.
If your plumbers ever need practice, like educating a skeptical homeowner, tell them to come and talk to me, and I'll be like, look, you need to educate me better than that, because like that don't make no sense to me. It sounds fishy.
Mike the trainer.
I'm Mike the I'll play the customer, and I'll let you know if you've convinced me or not. Okay, so we talked about that. Now, did we remind me if we covered this enough in depth? Are there symptoms that, I mean, you mentioned the one, but I want to see if there are other symptoms of knowing whether their PRV has failed. So you talked about like, okay, if you open the faucet and you get a sudden rush of pressure and then it falls off, then your PRV is probably, seen better days. You might need to replace it. Are there other symptoms like that you don't need a gauge? You're just looking and you're like, I'm experiencing this. More than likely the PRV has failed.
Drippy faucets.
Okay.
If you're seeing, more than one faucet dripping, that could be an indicator that you have high pressure.
Okay. Good.
Especially, I mean, oftentimes if you open a kitchen faucet and you see the faucet jump a little bit, the actual spout jump a little bit and move.
Looks like I'm going to be making a video about replacing my PRV.
Then there's, or the same, on the same token, you open it and the water comes out really fast for half a second and then slows down. Well, it's probably failed because it's allowing that higher pressure to come in.
Is it possible that when you get that, because when you said the faucet jumps a little bit, in my mind I actually heard a noise as well, because it goes right. so is it possible that your faucet's just loose? That like it needs to be tightened up, and like 75 pounds of pressure is going to make that thing jump a little bit? Or is it more than likely, if you've never seen it before?
If you're hearing the thunk, it's the pressure regulator.
I'm hoping that maybe I heard it somewhere else. Maybe it wasn't at my house.
Maybe it wasn't there.
It was in your head.
I don't know. I had a very visceral reaction though when you said that. So like I'm thinking it might be at my house. I have to go pay attention. Sometimes we get nose blind like to the things that we deal with every day, but that seemed like a,
Well, and that's that very first question you ask, is there anything a homeowner can tell?
Yeah.
No, not really, because
Gotcha.
They live it every day.
Well, now they will, because they're watching this episode and they're going to like say, okay, well, I'll pay attention to this.
That's why I said that.
Right. That's good. We just we just saved lives.
That's about the only fixture that I can really say that you kind of see it or feel it on.
Are there any effects to the toilet? What would they see with the toilet? Because when I think of a toilet going wrong, you think like, oh, it runs, but that could be the flapper, it could be the fill valve. Like, is that going to be a pressure?
Toilet would be hard.
It would be. It'd be hard because it flows such amount of water. It's hard to tell whether the very first little bit is going and then it slows down. I mean, if you had the lid off, you might be able to tell a little better, but it's still.
Okay.
It's just flow. I mean, it comes out fast for a second, and then because it doesn't take much to bring it down to that static pressure.
Okay.
Kind of thing.
Anything else you want to talk to these folks about PRVs, pressure reducing valves?
I don't think so. I think that covers it. Just reiterating the importance of it. It really is going to protect your system, not only just your faucets, but in your water heater, but all of your pipes and everything. It's a very important component.
If you made it this far in the show, do me a favor, leave me a comment below. Are you curious what your house pressure is? Do you know what it is? Are you going to run out and buy one of those water pressure gauges and check? Let me know in the comments. That's the show. We'll be back next Tuesday with a new episode of In the House. I've been your host, Mike Wilson, and you've been listening to In the House. Wait, if you want to know more about Any Hour Services, check out anyhourservices.com. See ya.